In this video, we're going to talk about some integration facts for e to the x. So as we know, the derivative of e to the x is e to the x. So the integral of e to the x is e to the x plus c, a constant. Okay. What this does for us is that if we have something like 3 e to the x that we need to integrate, the 3 is a coefficient that just hangs out. So I would get my 3. And then the integral of e to the x is e to the x. And then, of course, plus c. Pretty simple. What happens if you have other stuff in the exponent? So e to the 2x, let's say. All right. Well, remember that when we take a derivative, I would get 2e to the 2x. But if I want to go backwards, instead of multiplying by 2, we want to divide by 2. And just as I have shown before, you can check your integration by taking a derivative. So the derivative of 1/2 e to the 2x would be e to the 2x times 2, and that 2 and 1/2 would cancel. All right, so as a general fact, we're going to add to our pile. If you have any constant a up here, then when I integrate this, I would get 1 over a e to the ax plus c. All right, let's go ahead and practice a couple with this rule. So instead of multiplying by a, I multiply by 1 over a or divide by a. Okay. So if I had the integral of e to the 5x, this would integrate to e to the 5x, but I'm going to divide by 5 or multiply by 1/5. All right. If I had e to the negative x, all right, when I integrate, I get e to the negative x, but I'm going to divide by -1. So this would be the same thing as negative e to the negative x plus c. All right. In business applications, we see, at least in our textbook, we see some funky decimals as the exponent. We can still use this rule even if I have a funky decimal. So in this case, it'd be e to the 0.2x and then 1 divided by 0.2. Okay, and 1 divided by 0.2 is the same thing as getting 5e to the 0.2x plus c. All right, I hope that works.